Hello, this is Kazuki Motohashi. I'm a professor at the University of Tokyo. In this video tape, I will explain about our innovation discovery machine, particularly focusing on why we can predict the future market. So our innovation discovery machine is using machine learning model based on bibliometric information, something about research paper, patent, and company product information from website to predict based on particular type of technology for the market or products for each company or some patent or university. So how those technology could lead to the actual products. And so kind of you are predicting some potential products out of a particular type of technology. But of course, nobody knows what is happening in the future. And basically what our model is based on the data set in the past. So whatever happened in the past are not always coming, true in the future. So we are basically economics scholars focusing something. So we use some economic model to predict any type of economic event in the future. But those of the models are based on past events. So basically, in the future, lots of uncertainty. We cannot predict. We don't know what will happen in the future. But there is the one, very important actually fact in the world, which is saying that the future is always here. It's not just evenly distributed. So we could, so basically, what we try to do is fit some particular type of environment for some future, so which is a technology opportunity, market opportunity based on some technology, is coming in highly likely. So of course, we cannot, show that this is a thing that 100% for sure in the future. But maybe, if you carefully choose some environment, then we could predict or, something like a high probability of some kind of product will be coming out based on some particular type of technology. So, so those, how to select the environment is based on our scientific research. So one is our research linking research paper and patent, and how scientific finding in a research paper leads to the patent. And so basically, what we have found is the scientific frontier expanding regardless of technological development. But the technology, some of the, particularly for the science-based technology, like pharmaceutical industry, material science, something like, data science, like AI. So in those fields, we can see that technology follows science pattern. So which means that if there are some, scientific, important scientific finding, then those things could say something about future technology out of, those, basic science as a base. And number two is, so recent AI, so which is a machine learning technique, could complement narrow-sighted human being. I mean, so human being, so we make some judgment day by day based on our private knowledge. But those, machine learning, AI, could use huge, domain knowledge in the world. So outside your private knowledge, so individual private knowledge one by one, but use huge, information in a publicly available. So so those, some pattern out of this could complement to a human being, which have some, sense out of, based on his or her experience. Okay, so here I briefly introduce, of course, there are some other video which explain more detail about this innovation opportunity discovery by myself. But basically, so we use scientific research. So the paper, and then there are also information about the technology and also, product information. We basically scraped out of the company website. And those of, research paper and patent are linked by author or inventor of the patent, individual base, and patent and product can be linked by applicant base. So applicant of the patent and some company, so which are the applicant, or maybe it could be some university, and so who have some product out of actually web page. So basically we do some predictive model from here to here and here to here. So one of the actually things I discussed, like general pattern found in technology for science are coming out of this paper. So this graph is basically talking about a change in actually science space. So there are 20 years of observation, and we see that how scientific progress happened in variety of field like pharmaceutical, biotechnology, organic chemistry, blah, 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 digital communications. So the higher the y-axis, which is something like pharmaceutical, biotechnology. So those field, there is a huge scientific progress. And so y-axis here, horizontal axis, is so basically measuring technology dynamics. So here we look at patent side, so which sees that how in 20 years, like 1990s to 2010, and how each type of technology progressed very much. So there are some field like, so we call this one the science-based industry. So positive relationship between science progress and technology progress. And so when you look at carefully about the data set, then we see that basically, science frontier expand and technology follows because we have a so-called panel data set. So we have a timestamp each patent and scientific paper. So that's why we could see that which drive which. And basically what we found is those, particularly for those type of pharmaceutical biotechnology, microstructure and nano, fine chemistry, those area, mainly we can see that the more science progress, the technology is kind of exploits these things. But this pattern is not universal across technology. So for example, you can see here like digital communication, furniture, games. So those are the basically technical progress is very rapid, right? Because this y-axis is large, but it's not science-based, it's not so big as compared to these things. So those, maybe technological progress are coming from like a market requirement. For example, like a digital technology, that wireless telecommunications change their technology from analog to digital and 2G, 3G, 4G, 5G, and now, they are developing sixth generation wireless telecommunication technology. So those basically, this development is coming out of market needs to have faster, telecommunication speed and maybe secure, system. Okay, so number two. So how we can, use this, what kind of environment we can fit in. So for example, like we pick up some company and how this company are positioned. So based on their environment for particular type of company, or maybe we can pick up some patent from university and how this patent or technology at the company could be released into the market. And here, basically, our database is global. So we are basically currently based on Japan, US, and China, information. So we use, again, so as I talked to you that this technology and the patent, so those, linkages is made by company level. So we use the company information about Japan, US, and China. And we are extending our data set to Thailand and Vietnam and India at this moment. So again, so future is already here, but not evenly distributed. So maybe, something happening in a Silicon Valley in the US, but it's not happened in Japan or even, when you look into emerging economy like India or Thailand. So those countries are catching up. So which means that maybe, what happened in a developed economy could actually could be implemented there are some time lag for those countries. So we could use the actually training model of Silicon Valley applied to Thai company. So this is, basically we see so-called use some time gap. So again, so future is in Silicon Valley already, but it's not even distributed at this moment, like in a country in India or Thailand. So so we train our model using a so-called Nasdaq type firm. So which is kind of high-tech startup company. So they are actually even within same country like the US or Japan. So those country, those company which have tech-based startup, which is something listed in the Nasdaq. So those company, product life cycle theory is suggesting that they are more pioneering the new products out of particular type of technology as compared to the existing big company. Okay, so those model trained by Nasdaq type firm can be implemented to the big company. So big company have a lot of technology as a base. They have a lot of patents, know-how, and how they use this patent in the future market. Maybe you can see this answer existed in Nasdaq company. They're converting mechanism from technology to the market. So here is a potential application again. So I already explained these things in my other video, which talk about our system in detail. So input can be patent research paper, and output can be relevant market or potential business partners. Because when you see that, so this is typically the case for the university, because university are not doing, they have a patent, but they are not doing by themselves for product development, right? So they need to find out licensee of their patent. So here is something like what this system could do it. Okay, so tech-based company, tail of the universities, or VC firms can be a potential user for this system. And we can see that we could also do that some another way around, so which is input as a services and output as a technology. Okay, so here maybe we can suggest like a tech-based firm for R&D strategy. So what are the basically large firm seeking for the tech acquisitions? So you have some market already, but what kind of R&D, what kind of outside source of technology you can get to improve competitiveness of the products. So those are the things that could be used, which variable for the system to be used. Okay, so here is a example of one company. So for example, like this Hacto Co Ltd. So this is electrical device company in Japan, listed company, and so based on their technology here, then those are the market which is identified from a system. And here is sort of, their market to the something like a technology, development project. They better to do it. Okay, so here is so basically, business plan, development plan for these things. But at the end, so I like to stress that so our system based on our scientific research based of our team, and then so it's not just plug in something a black box type of machine learning model, but we carefully designed our model to fit it. Again, future cannot be predicted perfectly, but we could, when we select a good environment, then maybe you could see the future with high probability. Okay, thanks for your listening, and that's all for my presentation.